So yeah, today let's learn about numpy. Okay, what is numpy? Numpy is a type of library, okay, in Python which we use for mathematical operations or for using scientific things. Okay, if you want to apply complex mathematical operations and all, in that case we are using this thing. Or you can just say it's a library for scientific computing. Okay, where we can do multiplication of matrix. Okay, I think most of the things, okay, of mathematical things can be done here. Now, what are we going to do? What is the main thing we are going to use in NumPy? NumPy, the main thing we are going to use in NumPy is NumPy array. Okay, arrays. What are arrays? They are collection of similar data types. Okay, why we are using array? Because array give us high, means they are faster in calculations. Okay, they make our calculation fast, and they're specially designed for this mathematical operations. Okay, fine. Now, how many types of array we have? There are three types of arrays. Okay, one-dimensional array means there will be only one column. I mean rows. Okay, there will be only one row. Okay, 2D. 2D is a tabular data. Tabular data means where we have rows and columns, same as our matrix. Two rows, two columns, and all that, like that. It's a tabular data. Next, 3D array. It's a multi-dimensional array. We won't use that. Mostly we use 1D and 2D arrays. They are the two arrays which we are going to learn now. Okay. Now, what are the mathematical operations that can be do using NumPy? Dot product or inner product, we say multiplication of matrix and done. Okay. All these things, inverse, determinant, and broadcasting methods. Now, import. Importing means calling this library to our terminal. NumPy as NP. Now, this is how 1, 2, 3, 4. And see, this is what our arrays. Here, one thing to be noted that the arrays are not separated by commas as they are, but they are enclosed in a square brackets. They are enclosed in square brackets, but they are not separated by commas. This is the difference between array and this list. Now, now, just understand a few things about NumPy array. Okay, arrays can be built using previous data. Using previous data, arrays can be made. Okay, and the main difference between them is array is homogeneous data. Okay, and array are faster than the list. Okay, we can do faster operations compared to the list. Okay, why? Because they have fixed memory, they are ordered, and they're immutable. As tuples are immutable, arrays are also immutable, and it allows duplicates. Okay, it allows duplicates. Now, okay, number can be built using previous data types, previous data. Okay, they are homogeneous, they are immutable, they allow duplicates, they are ordered, and they have fixed memory. These things should be just have to remember these things. Okay. Now, coming to the next thing, 1D. Okay, one dimensional data. So, here now, how we are going to create 1D array? It's simple. The array which we created just now is nothing but one dimensional. This is the one dimensional array where you can see only rows. There is now. Let us take AR equals NP dot uh, array of 1, 2, 3, 4, 5, 6. We are creating an array. Print AR array. This is our array which has been created. Okay. Now let us explore our NumPy array. How we are going to do that? Nothing but let's do like this. If we write a dot shape and say, oh, okay, sorry, it's AR, right? Yeah, AR dot shape. ADA. What does this AR dot shape does? It is the shape of the array. Okay, how many? See, it's one dimensional array. No? That will just give you the rows. Okay, not the columns. Now, np dot shape is this. Okay, AR dot D type. Okay, they are int. All of them are int. Okay, data type, which tells the data type of the element data type. Okay, what is the data type of the elements? Now, AR dot size. Okay, what is AR dot size says number of elements which you have in the list. Okay, A dot ndim means tells about the dimensions. Oh, sorry, AR dot ndim. It is a one-dimensional array. Okay, and AR dot item size. These are the things which are important. Okay, that are must and sure you should do while you're doing if you want to explore any array. If you want to explore any array, these are must and short things which you have to do. See, item size means number of bits an element is taking. Okay, the memory size they say each element is occupying. Okay, so what is shape? So shape shape of an array, or you can say number of rows. It says rows. What does data type do? Tells about the data type. Data type of each elements. Okay. Size to its tell us the size. It's nothing but number of elements you can say, or number of elements you can say. Tells you about the dimensions, number of dimensions. Okay. And item size. It tells you about the memory size. Okay. Size. Okay. And this is what we're having about one dimensional array. Now, see. Now what you can do here. Now let's move to the 2D array. Okay. 2D array. Now, in order to create a two-dimensional array, what we'll do, we'll write np o equals np dot array of, we'll take a two-dimensional array now. 1 comma 2 comma 3 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8, and this whole thing again we are going to enclose in a square, means they are enclosing double square brackets. Okay, see, first this bracket. Now if you want to make it multidimensional, 1, again make a list to make second row, second column, 2, again 3, again 4, and so on. How are you going to do two-dimensional array? Okay, and if I write print npo, see, it's a two-dimensional array. P 3 by 3 matrix. This is how we can understand two-dimensional array. Is this part is going to tell us about two-dimensional array. Okay, now the same thing should we can do here. Okay, npo dot shape, see, 3 by 3, right? Npo dot see, 9 elements. 3 by 3, how many elements? 3 is the 9 elements, right? Now np dot d type, in order to find the data type. Oh, we should have changed the name. It's an integer. Okay, it is an integer. npo dot end name, how many dimensions? Two-dimensional array this is. Okay, this is how you're going to explore any two-dimensional array or one-dimensional array. That how we are going to access any data type. Suppose here, this thing we are having, right, in one-dimensional array, this one. Now, how we are going to access the element? Same as list, can we? Let's say, yes, you can accept, do them same as the list. Slicing is allowed. Okay, I just clear that thing as well. Yes, slicing is allowed here. Okay. Now, this is the main. The same thing can be done for here. Same, you can access the elements here. Okay. Here, just the main thing is NPO. Okay. 0th element. So now, whenever you write 0, it will keep things like, okay, you're giving it a, asking it for the 0th row, first row, second row. Or if you just give, I'll give you this. Okay. If you'll just directly give him 0. Okay, like this also you can get the rows. I think this is how it is applied. Now, a bit about mathematical operations, how we can apply the mathematical operations here. Okay. Now, AR plus NPO, we are having two. Okay, no. 1 second. Let us create an array. Okay. NP dot array of 8, 9, 5.2, 2. And let us enter AR1 equals and print AR1. Now AR1 plus AR, what are you saying? Okay, this gift of this is 4, right? So let us change it as 5,88. Now if I run C, AR, what is AR? This is the array which we are having in here. Here. This is the array which we are having in here. Okay. So what we'll write? We'll write here even print AR so that you can understand. This is AR and this is the rest of the elements. And have a look. They got added up. Okay, you can do AR1. So you can do the sum of that, sum of AR1. Okay. You can find the min element, min of AR1. You can find out the max element, max of AR1. And you can apply even statistical type. Now, NP dot mean. You want to find the mean of this, mean of AR1. See, this is the mean. You want to find the standard deviation, NP dot STD of AR1 can be done like this. You can find it in this. Okay, mean, standard deviation. Okay, min, max. You can do all these things using this. Okay, this is not about NumPy. Okay, NumPy uses NumPy array. Okay, that is the central thing which you have to know.